So these notes are on a couple of examples of special solutions to systems of linear equations. And they go with section 510 in the book. So we're going to do two examples. The first example is solve 3x minus 6y equals 3 and x minus 2y equals 1. So these are set up in such a way that I would really prefer to use the elimination method. And I can see that if I multiply my second equation, remember we'll label them A and B, if I multiply my second equation by -3, that's going to get me my x variables canceling. So I'm going to say -3b, -3 times x minus 2y equals 1. I distribute my -3 to all three pieces. -3x plus 6y equals -3. I now can combine a and -3b. So my a function is 3x minus 6y equals 3. My -3b function is -3x plus 6y equals -3. I add, and then I have my 3x and -3x cancel. That's what I was hoping for by multiplying by -3. But so does my 6y. And so does my 3 and -3. So I get down to this statement where 0 equals 0. This statement is true, which means that I have infinite solutions and they are actually infinite solutions that are all on one of these lines because they're actually the same line. So we say infinite solutions on the line x minus 2y equals 1. Now, I could have said infinite solutions on the line 3x minus 6y equals 3. It wouldn't matter which one I used here. The point being, though, that when I multiplied b equation by -3, it canceled with the a equation. Now, if I had chosen to multiply the b equation by just 3, distribute my 3x minus 6y equals 1. You'll notice that this equation is actually exactly the same as equation, small typo, 3 equals 3. This equation down here is exactly the same as equation A. So again, when I graph these two equations, they're the same equation. I'm going to get one line, x minus 2y equals 1, or 3x minus 6y equals 3, or -3x plus 6y equals -3. They're all the same equation. My second example of an interesting solution, a special solution, is to solve y equals 3x plus 1 and -3x plus y equals 5. In this case, because I have a y alone, I'm going to use substitution. So I'm going to take my second equation, and I'm going to put big parentheses where the y was, and I'm going to substitute in what I know y equals, so 3x plus 1. Now, in this case, the coefficient in front of my y is 1. So when I distribute or get rid of my parentheses, it doesn't actually change the numbers in the parentheses. So I have -3x plus 3x plus 1 equals 5. Well, -3x plus 3x is 0, so I get 1 equals 5. But that's false. So that means that I have no solutions. Let's look a little bit at why that would be. I'm going to take the second equation, negative 3x plus y equals 5, and I'm going to solve for y. So I'm going to add 3x to both sides. When I do that, I get y equals 3x plus 5. Now when I look at these two equations, we can see that they both have the same slope. Which means they are parallel lines. Parallel lines never intersect, so that's why they're no solution. So we say no solution, the lines are parallel, they never intersect.